So this is my walkthrough of my desktop display. Much of it is in the Studio Hand-in, and yeah. So I started off by knowing that I wanted some sort of kinetic installation, an art piece that was maybe going to live in the festival setting, that was going to be evocative and also have the themes of biomimicry and need to look natural as well. My first consideration was moss, but I moved away from that and started thinking about different paper tests. I knew this thing would need a surface that was going to be able to move and deliver me different material properties. Alongside this, I was started off by instantly making prototypes for how an undulation movement might happen. This was a 3D model that I found online that I thought I'd print out so I could see how it worked. And then this was a recreation of a tutorial I found online. Then I decided to make my own wave machine, and these pillars would go up and down, and the idea was for a material like this to sit on the surface of this so it could be undulated. So at this point I was already starting to break the project into two parts, which was the material that was going to be able to be seen on the surface, and then the mechanism inside that was driving movement and that was going to be hidden. I took this 3D print and I wanted to make a more substantial model. So I made it out in wood and I laser cut these things. I also at this point started to think about how I could power this thing, whether it would be human powered. In my studio submission, I talk about how this thing at this point might have been having a human powered element, or it might be motor powered. So I was just experimenting with that. At this point also though, it was still analog, and it was still this movement that was mainly pushed from different moving parts intersecting with each other. I also started thinking about, because I went to a material fair where there was lots of bioplastic experimentation, I started making some bioplastics out of a cookbook I found, different types of recipes with glucose and animal products. Then I inlaid wool into this, and this was a eureka moment that pushed me to put some wool on the outside, and this had a really lovely natural aesthetic to it, and it was also bendy. So I thought maybe I could develop this into a material that would fit on the outside of my mechanism. Then we go here onto different material tests, and it goes 1, 2, 3, 4, 5. This is where we started, something that was rigid and came apart very easily. And then eventually I got to this, which was very robust. It could be bended and reshaped and wasn't going to fall apart. I did this by inlaying wool as well as laying it on the top. Then this was a material experiment I did from this, and I noticed that this was going hard over time and it was becoming rigid. So I found out that this wasn't going to be suitable for the material I needed to go on top of my mechanism that was going to undulate. Alongside doing this, I was kind of making material design outcomes with it. This was a lamp, pictures of which are displayed in my studio submission. So it was nice how at this stage in the project that there was having some little design outcomes that were already started to round themselves off. I knew that I wasn't going to take this material forward, but it was nice to have this in some sort of products. From this, I then started experimenting with how I could 3D print onto fabrics and make my own fabrics that would be bendable. These are designs that I made on Rhino, and then started printing onto fabrics by gluing the fabrics to build plates halfway through a 3D print. So it started 3D printing, I laid down the fabric inside of it, and then 3D printed over that. This was a sort of natural pattern that I made and I modeled on Rhino. And then, and I was printing it on a type of mesh. And then I decided to swap to TPU, which is a bendy type of filament. And I designed this pattern that could stretch and move. Though at this stage I also decided not to go forward with this material because it was just too plasticky, and really the theory of the project was about how was about these natural aesthetics and bringing those natural aesthetics into products in our sort of indoor world. While these material experiments were happening, I was also doing mechanism experiments. So I had a chat with Matt about maybe looking at something more electronic to create this sort of kinetic movement, and it would give me more control into what I could do. So I started thinking about, if I was going to use motors to control this movement, how was I going to turn rotary movement, this spinning and this spinning, into linear movement, up and down. These are different models that I was doing. So this screw would screw and push this platform up. And then it was the same with this sort of thing, where this would screw and it would bring this towards this and push in and out as this screw would go in the inside. One of the initial experiments I did was this Scotch yoke, where you'd have a motor on this side and it would be pushing, it would be rotating this, which would be pushing this up and down. This was the mechanism that I decided to go ahead with, and I did different iterations of this until I reached this outcome, which was displayed at the interim show. This is where I realized it wouldn't work because too much friction was getting created in this. Even though I had added these ball bearings and improved the wheels from this in iterations, there was still too much friction. It was making too much noise and also too much heat. I started thinking about a mechanism that could drive central rods, which is this section here. I spent quite a few weeks developing different parts of these, and these are all central shafts that would fit into here with a motor on the back, and they would spin. On the outside would be a cylinder of the material that I was developing, that would be pushed and pulled by these points that were coming in and out. It started off with these steel rods. Then I worked to 3D printing these smooth parts that could have the cogs involved. And then I worked on these camshafts. They would have these little rollers on the outside, so you can see the development of the parts of this. I started like this with no room for ball bearings. Then I wanted to smoothen it out because it was still quite loud with ball bearings. It's using a cog in the middle that I had to break apart because I needed the motor back. The central cog would drive these outer cogs. Also, at the end of looking at this, the cogs were still making way too much noise and way too much rattling. I started considering friction gears, that you would use a rubber band and friction to push cogs instead of having these cogs that would rattle lots. Eventually, though, this was another failed avenue that I figured that was just it was getting too over-engineered. There was too many moving parts. I knew that there was going to be multiple of these within the installation. So there was just too many variables and it was too loud. So I decided to go back and do a simpler idea where I used a pulley system, just a winch wheel on here, pulling a weight up and down with one motor. It was almost completely silent instantly, and I started developing that for my final mechanism. When this was happening, also, I was learning about Arduinos. At the beginning of semester 2, I knew nothing about Arduinos or electronics. I met with our West Workshop technician, Malcolm, very regularly to learn about different lessons. Different lessons I could do, I learned off the Arduino website. Malcolm set me up with simple codes that I could go through and I could learn. I was also learning about stepper motors that were almost completely silent. I was taking them from derelict 3D printers that weren't getting used anymore, so that they were free to me. But they're more complex than a DC motor and take a little bit more coding. So I needed to learn, go back and get all the specifications. I needed to learn about like the current they would need, the voltage they would need, how to set them up with an Arduino, and they also need a stepper driver. With the stepper drivers, I then started to learn about the expansion boards that they go within. Another add-on to this was to make it an interactive installation. I started looking into ultrasonic sensors, and this was a way that my circuit could react from stimuli or stimulus and like people interacting with it. So if you held your hand in front of this, for example, the circuit would act or behave differently. It is also worth saying at this point that most of my work is in the studio document that I submitted, just because the nature of using using electronic parts, I need to, once one prototype is done, I need to take it apart and then use those parts for something else. I was considering how to wire it. This was what I was using to troubleshoot my circuits. At some point I decided to upgrade to an Arduino Mega. This is so I could fit multiple of my pendulum lighting onto one board. Although I decided to actually design for independency, so using Arduino Nanos, so that each light could perform independently. That's if this fails. So if this failed, the whole installation wouldn't fail. I was considering brackets, how the light would fit in here, how the motor would be on here, and how this would be hung. I originally started doing chains, then I started using braided steel wire because chains were just over-engineered. This is an example of the bracket of like what fits in the light. So this was pairing with the gravity pull mechanism, and then with the lovely paper outside that was going onto this. There was loads of different iterations of this that I just haven't been able to record, and loads of tiny improvements that were happening all the time. This is a top bracket, and then also on the bottom there was a bottom bracket that was getting pulled up and down. That's pretty much it from the desktop, and most of it is in the studio document.